Alright, so now we get to the really important topic of blocking. So when you were deriving your algorithms and you were using LaTeX and the Spark web page to typeset this, in the Spark web page you noticed there was this option of blocked versus unblocked. What's that all about? Okay, so here's the idea. Let's look at C equals AB plus C, matrix-matrix multiplication. And let's look at one of the loop invariants that came out for the algorithms that marched through the matrices by columns, matrices C and B. So this was one of them. Now, when you derived the algorithm for that, what did you do? You said repartition exposing the leftmost column of the right part of C. Do the same thing for B. And then you take this and you do a substitution into the loop invariant. And what do you get? You get that C0, C1, C2 is equal to A times B0 plus C0 hat, and then C1 hat and C2 hat. Okay. And that's then what we call the state before the update. That's step 6 in the derivation process. And then you did the same thing to figure out what the state after the update had to be, step 7. And then comparing step 6 to step 7, what you found out was that the update had to be, that C1 had to be updated with A times B1 added to C1. Okay. And then you can recognize this as a matrix vector multiply. And then when you implemented this with MATLAB, the update would have been something like C1 is equal to A times B1 plus C1. Right? Does that all look familiar? If you actually did the work, then this should look very familiar. All right. Now, the idea is as follows. For many reasons, which will become particularly clear in the enrichment for this week, when we talk about how to do highly optimized implementations of matrix-matrix multiply, which actually means slicing and dicing all over the place. You're going to find out that what you really want to do many times is not pick up one column here, but actually pick up some set of columns, and you want to compute with that set of columns simultaneously. Okay, so how does that change things? Well, instead of having a lowercase c1, which indicates a single column, we would then say partition exposing some set of columns where this here would be, say, B columns. Some kind of blocking parameter that you can actually tune, and depending on the situation you may want to pick that to be bigger or smaller. Okay, now if you do that here, then over here you would want to pick up B columns as well. But then you can do exactly what you did before. You can do a textual substitution, in which case for the state before the update, step 6, you would get this and this. For step 7, if you worked it out, you would get C0, C1, C2 is equal to A B0 plus C0 hat, A B1 plus C1 hat, C2 hat. And if you then compare that to that, and you ask, how do I need to inherently update? This C1 would become a capital C1 because now it's a submatrix. The B1 would become a capital B1, and this C1 would become a capital C1. And then in the update step, when you do this in MATLAB, well, first of all, when you would go to the Spark web page, you would indicate that you would want to use a blocked algorithm that then would actually expose matrices instead of column vectors, and then the update that you would end up doing would be C1 is equal to A times B1 plus capital C1. And what this means is that, well, this may seem a little bit silly to you, but what it means is that you're implementing matrix-matrix multiply in terms of matrix-matrix multiply. Actually, that's exactly the point. It may be that for this matrix-matrix multiply you would want to use a different algorithmic variant. And you're going to see that that's exactly the case when we talk about this in the enrichment. You'll want to partition in one direction, then you end up with a subproblem that's itself a matrix-matrix multiply, then you want to partition in another direction, you end up with another matrix-matrix multiply that's a subproblem of that, you want to partition again, and you want to keep doing that. Okay? So go and derive some blocked algorithms. For this particular operation it's going to be relatively simple. In the next section, what we're going to talk about is how you can cast other matrix-matrix multiplications with matrices with special structure in terms of matrix-matrix multiply by using blocked algorithms. And then hopefully everything will start coming together.